Welcome to another HVAC-Engineering-Techie training video. Today's video is on RCx Quick Fixes. And this explains how we do quick fixes and also how we optimize buildings. So this is another important module on the retro-commissioning process. Remember, this is the channel that talks all things HVAC. And remember, we would really like you to become a subscribing member. You just have to push the subscribe button down below. Give me a thumbs up if you like the video. Totally free, costs you absolutely nothing, no one will bug you. It's free to you and easy, but it's important to me because Google uses that data to evaluate the videos. So I'd really appreciate it if you do that. If you've already done it, thank you very much. I appreciate it. All right, let's get started on RCx Quick Fixes. All right, before we get started, we'll go through the videos that we have for these training modules. Cx-20 is the retro-commissioning process, 21 is the matrix. 22 is the pre-project planning, contracts and pre-project planning. 23 is pre-site activities. 24 is RCx system assessment and issue discovery. 25 is system testing. 26 is root cause identification, issue analysis. 27, this video, is quick fixes and system optimization. Turns out to be a really important part. Cx-28 is RCx corrective actions and post-project activities. So these are all the training modules we have for retro commissioning, and today's on Cx-27. So quick fixes. What's a quick fix? A quick fix is a repair, adjustment, or correction that can be performed during the RCx process without delaying the schedule. Normally, quick fixes are limited to those that take less than 15 minutes and require no purchase material. It's intended to remove issues that would cover up less obvious issues. Typical issues are deferred maintenance issues, cleaning of filters and pipe strainers, repairing loose control linkage or adjustments, unconnected flex duct repair or grill adjustments, removing obstructions to airflow, calibrating control sensors, correcting obvious airflow or flow issues, water flow issues. If you don't have the right amount of air and water, then it's going to possibly cover up other things, so you need to take care of those. And we only do those at this stage. So there's quick fix if they're drastic. If it's 10 or 12% out, that's not drastic. 25%, that's drastic. We need to fix that. Correcting obvious control programming or set point issues, that's important. But we don't go into detail. We just do the really gross outage. If you got a control programming or set point, the set point's 20-40% out. We got to change that. If it has other programming, we can fix that later. But for this particular quick fix, it needs to be quick fix as we go through. Normally, quick fixes are defined in the RCx contract as to how they are done, by whom, and how they are paid for. So remember, quick fixes cost money to do, so we have to have that in the contract or how they want it done. Normally, quick fix technicians are kept available during the RCx process to perform the desired quick fixes as the process unfolds. Quick fixes may be performed by the owners, operators, and maintenance staff. This is the way I like this one a lot because that keeps them involved with our process directly. And normally on staff is the people with the right talent to do the fix. Normally if it's a big building or a big customer, he'll have a technician of all kinds available to you, electrical, mechanical, plumbing, control technician, all of those could be available to you. And then anything they don't have, you would probably have, like the tab capability and things like that. Owners, outside service contractors, many owners have job order contractors or job contractors. And these contractors, of course, are already hired by the customer and work on a job order situation, and they may want to use those. Or the RCx providers, technicians may do it themselves. If you're capable of doing that and it's in the contract and the customer is okay with that, then you can do it directly. Either way is okay. Any of these ways are okay, but we need to get the quick fixes done hurriedly. It can't, you find a quick fix, it has to be taken care of the next day or so. It can't wait 2 or 3 weeks. It has to be done quickly. And sometimes that's why the owners, operators, and maintenance staff can't do it. They're too busy to do it. And so there needs to be maybe some other way to do those. Quick fixes must be done before any final issue analysis or root cause analysis are finalized. We like to have the quick fixes done while we're still there. 10 or 15 minutes now. It would be really good to have it that way. Issues that will interrupt the RCx schedule will require purchase of material and scheduling labor should be done as a correction, not a quick fix. So if there's something you got to buy material for, you have to do it unless the owner's doing it. If the owner's doing it, then he can do that process, and you'll just have to remobilize on the area and do it later. May be done concurrently with the RCx process. May be done as a corrective measure after completion of the main RCx discovery, depending on how big a deal it is. I mean, obviously, you have a piece of equipment that's totally broken and it's going to take 2 months to fix. That will be after you're done. So you're not going to be able to do that. Quick fixes require a quick fix report that lists each adjustment or correction made, who performed it, date and time of fix, why the fix was performed. So in other words, in your report, you're going to end up with a quick fix report to tell the customer of everything you did, what its impact was to him, and what its results should be. So you're doing that. Now, sometimes quick fixes are done for comfort, and you can't really calculate what the fix is. If it's something else, you might be able to do that. So what does an envelope quick fix look like? Quick fixes that are affecting system performance or preventing correct operation. Quick fixes may include adjusting door sweeps. This is typically wrong. I mean, door sweeps wear out. A lot of times there aren't any door sweeps left. Or if they are, they're not adjusted down to properly do it. A door sweep, of course, is a brush that sweeps the bottom threshold of the door to prevent, restrict airflow back and forth. Doesn't totally seal, but it does restrict it. Sealing air leaks in walls. Repairing door seals or window seals to prevent air and water intrusion. Adjust door closures so the doors actually close on time. Might be others, might be insulation, something like that. Mechanical system quick fixes, same thing. Change air filters, deferred maintenance issue. Cleaning air coils, drain pans, and changing air filters, which is part of deferred maintenance. Cleaning air coils, drain pans, and condensate drains, those are deferred maintenance issues. Changing and adjusting fan belts, another deferred maintenance issue. Correcting vibration, isolation, grounding, another deferred maintenance issue. Cleaning pipe strainers, sealing ducts, sealing duct access doors for panels. Now, normally we only do this when we notice it and it's big. Most ducts have leaks, and we're not going to go through and try to seal the entire duct line, but we are going to try to take care of some big ones if they're there. Reattach flexible ductwork, all those things. Electrical quick fixes, changing fuses or motor overloads, another deferred maintenance. Changing overloads, broken or pre-programmed electrical breakers, reprogramming VFD motor controllers. Those kind of things can be important. Control system quick fix, changing system operation schedules. These are things that operators will change to try to fix an immediate problem. And if they blow out a schedule and have a unit running all night to try to get somebody happy in the morning, you need to change that back because you need to find out what the original cause was, why they did that. Changing control system set points. If you have a set point way out of whack, we have to change that. Inputting sensor calibration offsets, removing set point and equipment overrides. Activating a change or reset sequence. VAV or CVA, constant volume box calibration. That can be a quick fix. Operator training to correct and control operation deficiency. That can actually be a quick fix if you have to stop and train the operators. Tab quick fix, resetting dampers, unblocking grills and registers. We can't have them blocked. Obviously, if you find cardboard taped over a grill, the people are too cold in the space or too warm in the space. Resetting air handlers or fan coil unit airflows with a significant variance from design. And by normally we mean, not just over 10%, but quite a ways out. Adjusting outside airflows for building pressurization. VAV box calibration. Adjusting water flows with significant variance from design. Adjusting duct or pipe pressure differential set points. Correcting economizer or airflow balance. A lot of things there for tab. Plumbing system quick fixes. Resetting incoming water pressure, adjusting water pressure boosters, adjusting hot water temperatures, correcting system or fixture leaks, adjusting flush valve flows. Those are things that help plumbing. Provide lighting quick fixes or lighting schedules. Make sure that the lighting is on the right schedule. Correct or adjust non-functional lighting controls. Cleaning dirty fixtures that are preventing light from reaching the space. If you've got tubes, fluorescent tubes, or even LED tubes, as the lenses get dirty that start restricting light, those need to be cleaned. Plug load fixes, not many we can do here. Turn off unused devices such as computers or monitors. And that's a training issue to try to train the occupant to say, these are putting heat into the space. Can you please turn them off when you're not using them? Remove any unused electrical appliances from space, such as heaters, refrigerators, fish tanks. That's a political issue. You are not going to be able to do that, but maybe the owner can. Must have owner's approval for any plug load changes, maybe a political issue rather than a physical issue. You'd like to, you see them there and you go, this is something that's affecting us. So what's a facility guide? And part of our process, if you read the standard, is that we issue a facility guide to the owner. And a facility guide provides to create facility operating guide that includes system schedules and standard set points. So what this guide is, we're going to give it to the operator and say, this is actually how you operate the building to keep it in the shape we've been able to put it in. So we fixed a lot of problems. We want to keep it that way. And to do that, this is how you operate the building. Now, at first glance, that seems like, that's going to be a big job. It turns out it's, a couple hours work. It's really very easy to do. System schedule and standard set points. This is what we want you to use. Functional description of system operating parameters to meet performance goals. So they understand this is how it's supposed to operate. Believe it or not, many operators don't really understand how their system operates. And that's unfortunate, but you will figure that out as you go through working with them. Operator instruction for all systems, how to start up, shut down, and operate during emergency operations. So you're going to put in your facility guide. This is how you start up a system. This is how you operate the system when it's running normally. Here's what to do when it's in emergency mode, and this is how you shut it down. So that's all important of how they actually operate the system. And then you do the same thing with maintenance. This is how you maintenance the system, and this will come out of the maintenance manual. This takes the most time. Operation is really pretty easy. Functional test scripts for critical system tests. We provide them these functional tests and say, okay, here's how you actually test the system when you need to test it. The facility guide is used by operators to maintain the system performance obtained by the RCx project. So optimization, what is optimization? Now, I think somewhere earlier in one of these videos, I talked to you about the definition of optimization. Let's see if I put it in. Yeah, here it is. Now, the reason I'm saying this is because Webster calls optimization to make perfect. And that's not our definition. So you need to make really clear that the customer knows what our definition of optimization is. Optimization is the process of adjusting operating parameters, operating techniques, and control sequences to maximize performance for each system and between systems. So we're going to make it work as what I say elsewhere in the definition is as practical possible. You can't get a system to be perfect. And we're not trying to make perfect. We're trying to make it the best it can be with what we have. Sequence and control corrections, fine-tuning set points, fine-tuning reset sequences, loop tuning, final adjustments in air and water flows, utilize a continuous performance testing system, modify operator standard protocols for improved performance. So these are the things we're trying to, we've already fixed everything, and now we're just trying to make it work as best we possibly can with what we have. Remember, I originally told you that retrocommissioning is the lowest possible cost method of making a building work with what you have. We're not replacing whole systems, but we are trying to fix everything so it works the best that it can. System optimization performed on both systems found with issues and systems found without issues. Since optimization will enhance performance for both systems. Remember in the standard, we did that original testing, to find what systems weren't working so we could concentrate on those. No sense in trying to fix something that's not broken. Well, during optimization, we're going to do it to both systems. The whole building gets optimized because you can't do just one. Just because it's working, it's probably not optimized. So we will optimize both. The provider is to assess the capabilities of the existing operating staff to operate and maintain the facility to achieve performance levels. Now, this is tricky. I originally also told you you don't criticize the operators and you make sure they understand you're not there to get them fired. You're not there to blame them. You're there to help them make a building. Well, as you go through that process, you need to evaluate how good is he at what he does and does he have the right training? Does he need some more education? And you're doing this so you can tell the owner, look, you got some really good guys and you got one or two that are really good, but they need to have some more education. and then you can recommend to him what to do. The provider to conduct hands-on training when needed during the RCx process. This is another reason why it's really good to have the operators with you. Now you're actually training them. Everything you do, everything you touch is a training event. And if not, you may have to provide formal operator training for the operator staff as needed to provide formal education and training for optimized system performance. Many times I've had to say, okay, let's convene first thing at 8 o'clock in the morning in your office. We're going to have a little training session, and I'll explain to you how your system works. You know, if you find the staff doing things that are totally detrimental to the system because they don't understand, you need to stop that as soon as you can, because if you don't, you fix something the next day, they unfix it for you, so you need to keep that in mind. So utilize a continuous performing tracking system, which we call a CPT system, to verify system performance over time. And you can see CX8 training session specifically for CPT system. If you don't measure something, you can never make it better. If you don't know how well it's working in the first place, you can't make it better. Normally, it will slowly erode over time. So that's what these systems are. Now, they can be really system, just a spreadsheet where you keep track of stuff, or they can be a full-blown fault detection system, an FDD system, which is expensive, but that's going to do the same thing. So you can use either one. When degrading performance issues are discovered, use an RX approach to isolate and correct all issues found. So the CPT system has a methodology of it to kind of watch what's happening. As the performance degrades, then you switch back to your RCX hat and go through and try to figure out what's wrong. So it's pretty easy process. And here's the process. You have a plan of how this works. You collect the data, you analyze the data, you normalize the data. You use baselines if you have them. If not, you compare the results to past results. Are we getting better or are we getting worse? If you're getting better, pat yourself on the back and keep going. If you're getting worse, well, now we need to fix it. So then if it's getting worse, then you make changes. You figure out what change is going to help it, and then you verify that actually worked what we changed, and then you start over. And this is just a big circle happening every month. Normally we do it every single month. And this process will allow you to get better and better and better because you're measuring the results. And this is the only way I know to help an operator do a better job. If the operators don't know they're doing a bad job, how are they going to fix it? They're not going to fix it. So you need to have a system that actually tells them. And this is really simple, but it's very, very effective. So that was a very short video. I hope that was helpful. I really appreciate you watching the video, and I will catch you on the next one. Have a great day.